This week portion, photoelectric effect, radiation pressure, matter waves. Okay, read the question. Meanwhile I'll adjust it. Read the question. Next, how the photoelectrons must be ejected. Normal to the photoelectrons will be ejected normal to the metal conducting surface here, that one. Here they're just inclined so that light will fall. So or else we can put it vertical only, that condition. So usually what happens, again, if we check the original, that particular thing in our books, they didn't mention the electrons that are ejected, photoelectron will be ejected normal to the metal surface. The other one prior condition that we are not considering much. By default, we should assume that one only. What about here, sir? Then they will be they'll be ejected normally. As here they ejected normally, they go like this. They will not reach here. So the setup what happen? So you can assume it. There's a plate 1. The light, what will happen? There is some point source of light. So the light emitted by it. So I think this should have been the better diagram, I feel. Huh? And this is that V0. There's a plate 1, plate 2. It's having a work function Φ1 and Φ2. This will be ejected with kinetic energy. This electron will be ejected with kinetic energy K1. This electron okay, Ka, I'll write it, and this will be ejected with a kinetic energy Kb. Find the wavelength of electromagnetic wave used here. Assume photoelectrons emitted from either plate do not interact with each other. Now look at this electrostatic field. Directly come, take a positive. Don't go in this. This is a positive terminal. Now, sir, which is collector, which is emitter? Both are emitting, no? And both will collect. So don't call anything collector, emitter. Now look at the polarity now. The positive terminal of cell is connected to plate 1. So therefore the electric field will be in this direction. So just put that E bar in that photoelectric tube. Rest all everything you can manage. This electron emitted by plate 1 will experience a force towards left, no? And the electrons emitted by the plate B or the plate 2 will experience force towards left. So the electrostatic force does negative work on the photoelectrons 1 and does positive work on the photoelectrons 2. So let's get into what is Ka. Ka should be equal to Sc by lambda minus work function. What is Kb similarly? Sc by lambda, the same lambda. Next, after this, the electrostatic force does negative work, no? So by the time this electron reaches there, I'll give color. This, let it be red color. So by the time it reaches here, it will have K1. And this will be KB. By the time it reaches here, K2. And the electrostatic field is in the direction. This is very important because that will help us to write equation. Write down the equation of the electrostatic force does negative work on this. So what should be this one? Ka, work done by electrostatic force should be equal to, it does negative work, E into V naught should be equal to K1. Then Kb, electrostatic force does positive work, should be equal to K2. What is the unknown thing? So we know V naught in E, K2 work function. So lambda is unknown thing. Solving for that will get the required answer. Yeah, fine. I think somehow you should understand the basic things here, no? Nothing big, especially this chapter.